The first time traveler might have already come and gone. We are going to explore 30 of the most fascinating, bizarre, and scientifically grounded theories about the universe's very first journey through time. By the end, you will have a completely new framework for thinking about reality itself. We will see how ancient myths might hold hidden truths, and how the very laws of physics could be the result of a temporal paradox. This is a journey to the edge of cosmic understanding, where the beginning of everything might also be its end. What feels most impossible to you about the idea of time travel? The first theory is a cosmic riddle that questions the very origin of everything. It is called the Big Bang Bootstrap Paradox. In simple terms, it asks a startling question: what if the universe created itself? The idea suggests our cosmos is a closed time-like curve, a loop in time where the end connects back to the beginning. Imagine not a straight line from the Big Bang to today, but a circle or a cosmic Möbius strip where one side seamlessly becomes the other. In this view, the precise conditions needed for the Big Bang to explode into existence, the exact amount of matter, the perfect balance of forces, did not come from nowhere. Instead, that crucial information was sent back in time from the universe's own future. A piece of the mature cosmos, perhaps a fundamental law or a seed of physical data, traveled backwards to the moment of creation to ensure its own birth. This is the ultimate bootstrap paradox, where the universe pulls itself into existence by its own future bootstraps. For physicists, this wild idea actually solves a profound mystery known as the initial condition problem. Why did the universe start in such an incredibly specific, orderly, and life-friendly state? The conventional answer is we just got lucky. But the bootstrap theory offers an alternative. It was not luck, but a form of cosmic destiny enforced by time travel. The universe had to start that way because its future self mandated it, creating a perfectly self-consistent loop where cause and effect chase each other around a circle with no true beginning. This touches on deep concepts in quantum cosmology, where the boundaries of time become fuzzy. It paints a picture of reality not as a one-time event, but as an eternal, self-sustaining cycle. A loop where the first moment and the last moment are, in fact, the same moment. But a self-creating universe is not the only way to seed time travel into the cosmos. The second theory takes us to an even more remote and bizarre frontier, to a moment so early that time itself may not have been fully formed. This is the idea of the quantum gravity pioneer. It proposes that the very first journey through time was not undertaken by a conscious being or even a machine, but by a fundamental particle or a tiny knot of energy itself, a random fluctuation in the seething chaos of the primordial universe. To understand this, we must shrink our perspective down to an almost unimaginable scale. We are talking about the Planck epoch, the first sliver of time after the Big Bang, a duration so brief it is written as 10 to the power of -43 seconds. In this fleeting instant, the entire cosmos was smaller than a single atom, and the four fundamental forces we know today, gravity, electromagnetism, and the strong and weak nuclear forces, were fused into one unified superforce. The fabric of spacetime was not the smooth, stable stage we perceive now. It was a turbulent, frothing sea known as quantum foam, where spacetime itself bubbled and churned with violent, random fluctuations. Within this quantum foam, the very concepts of before and after break down. Under such extreme conditions, the theory of quantum gravity suggests that microscopic wormholes could spontaneously form and vanish, and that the distinction between space and time could become blurred. It is here, in this primordial chaos, that our pioneer emerges, a single particle or a ripple in the fabric of reality, born from a random quantum fluctuation, might have encountered a natural time loop, a microscopic wormhole that connected one instant to another. Through sheer random chance, this particle could have taken a shortcut not just through space, but through time, appearing an incomprehensibly tiny moment in its own past. Think of it like a bubble forming in a pot of boiling water. Most bubbles rise and pop at the surface in an orderly sequence, but in the furious churn at the very bottom of the pot, one tiny bubble might get caught in a turbulent eddy, swirling back down for a fraction of a second before rising again. In the quantum foam of the early universe, spacetime itself was that boiling pot. A particle could have been that bubble, briefly caught in a temporal eddy created by the warped geometry of infant reality. This would not be a grand, orchestrated mission. It would be a random, natural event, the universe's first accidental time traveler. The profound implication is that this single, random jump could have had a cascading effect. By interacting with its own past state, even in an infinitesimally small way, this pioneer particle might have altered the probabilities of subsequent quantum events. It could have tipped the balance, acting as a seed that influenced how the universe cooled and how the forces separated as it expanded. In this view, the very laws and structures we see today, the fact that stars formed and that chemistry is possible, might trace back in part to a forgotten quantum accident, a fleeting journey through time when the cosmos was still taking its first breath. This shifts the narrative from a conscious act to a natural, almost inevitable feature of a universe born in quantum uncertainty. It suggests time travel is not a technology to be invented, but a relic of creation itself, woven into the fabric of reality from the very first moment. That random quantum pioneer, if it existed, would have been a solitary speck in an ocean of chaos. But what if the first time travel was not a single event, but a fundamental feature woven into the very expansion of the cosmos? This brings us to the third theory, the cosmic inflation time loop. To grasp this, we need to revisit one of the most successful ideas in modern cosmology, cosmic inflation. For a fleeting fraction of a second after the Big Bang, the universe is thought to have undergone a period of hyper-accelerated expansion, inflating from subatomic size to something vastly larger in an eye blink. Space itself stretched faster than the speed of light, smoothing out wrinkles and setting the stage for everything to come. But within this violent, exponential stretching, something strange may have occurred. The theory suggests that the process of inflation could have warped the newborn spacetime so dramatically that it tied itself into knots, regions of intense curvature where gravity became overwhelmingly powerful, might have formed natural tunnels or bridges in the fabric of reality, wormholes. And not just any wormholes, but ones where the two ends were connected not just across space but across time. These would be closed time-like curves, loops where you could, in principle, travel forward and end up back in your own past. Imagine the surface of a balloon as it is being blown up incredibly fast. Most of the surface stretches smoothly, but if you pinch and twist the rubber as it expands, you might create a tiny, twisted tunnel connecting one part of the balloon to another. Inflation, with its unimaginable energy, could have created countless such pinches and twists in the fabric of spacetime itself. These natural time loops, forged in the furnace of creation, would have been fleeting. As inflation ended and the universe settled into a more sedate expansion, most of these loops would have collapsed or been stretched beyond recognition. But their brief existence could have left a permanent mark on the cosmos. How tiny quantum fluctuations in energy and density could have traveled along these loops. A ripple in spacetime could have gone on a short journey into its own immediate past and then returned, interacting with itself. This self-interaction would have amplified certain patterns and suppressed others. In essence, these natural time machines could have acted as cosmic filters, shaping the primordial seeds of structure. The subtle variations in density they helped create would later, over billions of years, gravitationally collapse to form the vast cosmic web we see today, the great clusters of galaxies, the long filaments of dark matter, the immense voids of empty space. The large-scale architecture of our universe, the grand tapestry of galaxy clusters and superclusters, might literally be frozen music, a harmonic pattern composed by echoes traveling through time in the universe's first instant. This means the blueprint for our entire cosmic neighborhood, including the Milky Way and our own local group of galaxies, could have been drawn by the hand of time itself, in a process where cause and effect were not a straight line but a shimmering, self-referential loop. The structures we gaze upon in our deepest telescopes are not just relics of the past. They might be the enduring signature of the cosmos's first and most profound journey through time. These cosmic loops born from inflation are a breathtaking idea, but they existed in a universe still too hot and dense for any complex structure to survive the trip. For a more stable and perhaps more terrifying gateway to the past, we must look to the universe's first true monsters. This is the fourth theory, the primordial black hole gateway. It suggests that the very first time machines were not loops in spacetime, but singularities of infinite density, microscopic black holes forged in the inferno of the Big Bang. In the first chaotic second of existence, as the universe expanded and cooled, pockets of extreme density could have collapsed under their own gravity. These were not the stellar mass black holes born from dying stars, which came much later. These were primordial black holes, some as small as an atom but containing the mass of a mountain. And according to the mathematics of general relativity, some of these ancient objects could have been born spinning at a significant fraction of the speed of light. A spinning black hole, described by the Kerr solution to Einstein's equations, is not just a simple point of no return. Its intense rotation drags the fabric of spacetime around with it, like a whirlpool in the cosmic ocean. This creates a region just outside the event horizon called the ergosphere, where space itself is pulled along faster than light. More crucially, at the heart of a Kerr black hole, the mathematics reveal not a point-like singularity, but a ring-shaped one. And this ring singularity presents a bizarre theoretical possibility. If you could somehow survive the tidal forces and navigate the chaotic geometry inside the event horizon, you might pass through the ring, not into oblivion, but into a region of spacetime that represents a different time, or even a different universe entirely. Some solutions suggest these paths could be closed time-like curves, tunnels that loop back into the past. Picture a primordial black hole in the infant cosmos, a minuscule, swirling vortex of ultimate darkness set against the blinding fire of the early universe. Its incredible spin warps the surrounding spacetime into a complex, twisted knot. For a fleeting period, before these micro-black holes evaporated through Hawking radiation or merged with others, they could have served as natural, if lethally unstable, time portals. A particle or packet of information, by following an incredibly precise trajectory through the ergosphere and into the ring singularity, might not have been crushed. Instead, it could have been flung along a geodesic, a path through curved spacetime that circles back to a moment before it entered. This journey would not be a controlled voyage. It would be a desperate, chaotic plunge through the most violent environment imaginable, a cosmic game of roulette where the prize is a chance to rewrite a tiny piece of history. The profound implication is that the early universe may have been littered with these natural time machines, billions upon billions of them, each a potential gateway flickering in and out of existence. While most matter falling into them would be utterly destroyed, the rare, perfectly aligned quantum of energy might have completed the loop. This means the initial conditions of our cosmos could have been subtly edited, not by a grand design, but by countless random particles taking a 1 in a trillion chance and winning, their reappearance in the past minutely altering the probabilities of quantum events around them. The fabric of reality we see today might be the result of a primordial lottery, where the first tickets were drawn inside the spinning hearts of the universe's oldest and smallest black holes. Black holes may have offered a chaotic lottery, but what if the universe itself decided to ban time travel altogether? This leads us to the fifth theory, a fascinating idea that turns a famous scientific argument on its head. It is called the chronology protection conjecture's first test. The legendary physicist Stephen Hawking once proposed a famous idea. He suggested that the laws of physics must contain a built-in mechanism, a chronology protection conjecture that prevents time travel to the past. His reasoning was elegant. If time travel were possible, we should be overrun by tourists from the future. Since we see no such visitors, the laws of nature must forbid it. But our theory asks a deeper question. What if that law was not always there? What if it was created as a direct result of the universe's first attempted journey through time? Imagine the early cosmos, a realm of pure potential where the rules were still being written. In that fluid state, a natural time loop forms, perhaps from a spinning black hole or an inflation knot. Something, a particle, a bit of information attempts to travel back. But this journey creates an immediate problem, a paradox. Maybe the particle interacts with its past self in a way that would prevent its own existence, or it creates an impossible loop of causality that threatens to unravel the logical consistency of reality itself. In that moment, the infant universe faces a crisis. The paradox is like a fatal error in the cosmic code, a glitch that could cause the entire system to crash. To preserve itself, reality reacts. It enforces a new rule. The physics of spacetime reconfigure at a fundamental level, perhaps at the quantum gravitational scale, to smooth out the contradiction. The time loop collapses, the paradoxical event fizzles out, and a new principle is woven into the fabric of existence. Consistent histories must be maintained. This is not a gentle adjustment. It is a cosmic immune response, a fever that burns away the infection of logical inconsistency. The universe's first brush with time travel literally gave itself a law against it, shaping the physics we now take for granted. The smooth, paradox-free timeline we experience today would then be the direct result of that primal correction. We do not see time travelers because the universe long ago healed the wound that made their visit possible. The chronology protection conjecture is not a timeless truth, but a scar, a reminder of the universe's first and greatest temporal crisis. That cosmic law against paradoxes might be the ultimate safeguard, but what if the universe found a loophole, a way to allow time travel without ever creating a contradiction? This is the sixth theory, the multiverse branch point. It proposes that the very first journey through time did not go to the past of our timeline at all. Instead, it created a brand new branch of reality, and our entire universe is the result of that first fateful divergence. This idea springs from one of the most mind-bending interpretations of quantum mechanics, the many worlds theory. In simple terms, every time a quantum particle faces a choice like which path to take through an experiment, the universe does not pick one, it splits. Both possibilities happen, but in two separate, newly created parallel realities. Now apply this logic to time travel. Imagine a particle, or perhaps a more complex entity, from the future of an early universe attempting to journey back. Instead of arriving in its own past and risking a paradox, its arrival becomes the quantum event that causes the split. The moment it appears, reality fractures. One branch continues as the original timeline, untouched. The other branch is the new universe, the one we inhabit, where the time traveler has always been a part of history. In this new branch, there is no paradox. The traveler's actions are just part of the established past, woven seamlessly into the fabric of cause and effect. Think of it like a tree growing from a single trunk. The trunk represents the original, pristine timeline of the cosmos. The first time travel event is like a deep crack at the base. Instead of breaking the trunk, the tree grows a massive new branch from that point. Our universe is that branch. Every star, every planet, and every one of us exists on a limb that sprouted because something arrived from a future that, from our perspective, never actually happened. This transforms the meaning of the first time traveler. They were not a visitor to our past, they were the seed from which our present grew. Their arrival introduced the specific conditions, information, or even just the quantum fluctuations that set our cosmic history on its unique path. The precise value of gravity's strength, the number of dimensions that remained stable, the very laws of physics we rely on, these might not be universal constants, but the local bylaws of our particular branch, imprinted by that foundational event. So when we look back to the beginning, searching for a first cause, we might be staring at the echo of a decision made in another reality. Our Big Bang could be less of a true beginning and more of a fork in an infinite road, a divergence point where our story broke away from an ancestor universe. This means every choice, every chance event in our history might be mirrored by another universe where things went differently, all sprouting from an endless tree of possibilities whose roots are tangled in loops of time. Our branch of the multiverse feels uniquely real, but what if its entire history is built on a single, corrected mistake? The seventh theory plunges us into the realm of digital metaphysics. It is the ancestor simulation glitch. This idea begins with a provocative premise. What if our universe is not base reality, but an advanced simulation, a kind of hyper-realistic video game run by a vastly more powerful civilization? This is the core of the simulation hypothesis, a thought experiment made famous by figures like Nick Bostrom. If such a simulation exists, its creators would need near-infinite computing power to model every particle and force from the Big Bang forward. But even the most advanced programmers might make an error. The theory suggests that the first time travel event was not a physical journey, but a patch, a deliberate rollback of the cosmic code by the simulators to fix a critical bug in their universe program. Imagine the early moments of the simulation. The code executes, space-time expands, particles form, but the simulators notice a fatal flaw. Perhaps the initial conditions were set incorrectly, leading to a universe that would quickly collapse or never produce stars. Or maybe a random quantum fluctuation, a Boltzmann brain, a self-aware entity that spontaneously forms from chaos appeared too early, threatening the simulation's logical consistency. To correct this, they do not restart the entire program. Instead, they implement a localized edit. They send a packet of information or rewrite a segment of code back to a specific coordinate in the simulation's past. From inside the simulation, this would look like a miraculous, law-breaking event. A particle appearing from nowhere, a fundamental constant shifting, a ripple in space-time with no clear cause. It would be the universe's first and most profound violation of causality, executed from outside the system itself. This glitch would not be a paradox, it would be a debug. The time travel is simply the simulators accessing an earlier saved state and altering the variables. Our entire cosmic history from that corrected moment onward is the patched version. Every galaxy, every planet, every one of us exists in the debugged build. This idea even offers a darkly humorous answer to the Fermi paradox, the question of why we see no other civilizations. Perhaps the original, buggy version of our universe was teeming with early life, but it was causing a memory leak in the simulation. The debug wiped them out as a necessary optimization, leaving a quieter, more stable cosmos for us to eventually emerge in. So when we probe the mysteries of the Big Bang and the fine-tuning of physics, we might not be uncovering the laws of nature, but reading the commented code of our creators, searching for the artifacts of a fix applied at the dawn of time. The idea of a cosmic debug raises a chilling possibility. Our reality might be a corrected error, but what if the most mysterious force in our universe is itself a correction? A message sent back through time to save everything from a silent, cold death. This is the eighth theory, the dark energy temporal engine. For decades, astronomers have known the universe is not just expanding, but that this expansion is accelerating. Galaxies are being pushed apart by an unseen force that counteracts gravity's pull. We call this force dark energy, and it makes up about 70% of everything in the cosmos. Yet, we have no idea what it truly is. The standard model treats its emergence around 5 billion years ago as a natural phase change, like water turning to steam as the universe cooled and thinned out. But this theory proposes a far more radical origin. What if dark energy is not a natural feature of empty space but an artifact, a retro-causal intervention from the far future, designed to ensure the long-term survival of the cosmos itself? Imagine a universe billions of years from now. Stars have burned out, galaxies have evaporated, and black holes have decayed through Hawking radiation. The cosmos is a dark, dilute sea of subatomic particles and photons, drifting farther and farther apart in an expansion that was once slow. In this desolate future, intelligent life, or perhaps the universe itself as a conscious, post-biological entity, faces an existential problem. The expansion, left to its original course, might eventually become so slow that the cosmos enters a state of effective stasis, a heat death where nothing new can ever happen again for all eternity. To prevent this eternal stagnation, a plan is conceived. Using a physics we cannot yet comprehend, this future intelligence manipulates the fabric of reality at its most fundamental level. It sends a command, a ripple in the laws of nature, backwards through time. This command is not a particle or a machine, but an adjustment to the vacuum of space itself. It programs into the past universe a latent energy, a pressure inherent to empty space that would remain dormant for billions of years, waiting for the precise moment when the universe's density dropped to a critical threshold. Then, like a time-released medicine, it activates. This is the onset of accelerated expansion we observe today. The sudden push of dark energy is not an accident of physics. It is a rescue mission. By ensuring galaxies are pushed apart faster, the future guarantees that the universe will continue to expand at a rate that prevents a premature, stagnant end. It creates the conditions for a more dynamic, if lonely, future, perhaps one where quantum fluctuations can still give rise to new possibilities over unimaginable timescales. From our perspective in the present, we see galaxies flying apart, driven by a mysterious anti-gravity. We are witnessing in real time the execution of a command sent from the end of time to save itself. Dark energy, then, is the universe's ultimate immune system, a self-preservation mechanism woven into history by its own future. It means the fate of everything was sealed not at the beginning but at the end, and then sent back to guide us all forward. A rescue mission from the future is one thing, but what if the first time travel was simply a message in a bottle, tossed into the cosmic ocean in hopes that someone, someday, would understand? This is the ninth theory, the neutrino message from the future. It shifts the narrative from cosmic engineering to cosmic communication, proposing that the very first journey through time was not a physical voyage, but a desperate attempt to send a signal across the ages. The medium for this message would need to be something extraordinary, a particle that could travel for billions of years without being absorbed, scattered, or corrupted by the intervening matter and radiation of the expanding universe. The perfect candidate is the neutrino. Neutrinos are ghostly subatomic particles, often called ghost particles because they barely interact with normal matter. Trillions of them pass through your body every second, coming from the sun and distant cosmic events without you ever noticing. They are nearly massless, chargeless, and can travel straight through entire planets as if they were not even there. For a civilization looking to send a message that must survive the fiery dawn of the cosmos and reach its very beginning, a neutrino beam is the ultimate cosmic telegram. Imagine a society in the distant future, perhaps facing its own extinction or having unlocked the fundamental secrets of reality. They want to leave a mark to prove they existed, or to send a warning or a blueprint back to the very foundation of everything. Using technology we cannot fathom, they modulate a vast stream of neutrinos. They encode information into the particle's subtle properties, their flavor oscillations, their energy spectrum, or their timing. Then they aim this beam not into space but into time, exploiting a theoretical loophole in spacetime to send it racing backwards toward the hot, dense plasma of the early universe. When these future-sent neutrinos arrive in the primordial cosmos, they do not appear as a structured radio transmission. Instead, they mingle with the trillions upon trillions of neutrinos already being forged in the Big Bang's furnace. Their encoded signature would be an anomaly, a subtle statistical pattern superimposed on the natural background neutrino fog. This could have had a tangible effect. Neutrinos played a crucial role in the first few minutes of the universe, influencing the nuclear reactions that forged the first hydrogen and helium. An anomalous influx of neutrinos with a specific artificial pattern could have minutely altered those ratios, leaving a faint but permanent fingerprint in the primordial abundance of elements we see today. Even more tantalizing, this neutrino message might still be detectable. As the universe expanded and cooled, the afterglow of the Big Bang, the cosmic microwave background radiation, was imprinted on the sky. Some cosmologists have pointed to strange, large-scale anomalies in this background radiation, features like the so-called cold spot or unexpected alignments that our standard models struggle to explain. Could these be echoes not of the Big Bang itself, but of a later intervention, a pattern etched into the cosmos by a signal from the future, the famous WOW signal, a powerful, narrowband radio burst detected in 1977 and never explained, is often cited as a potential candidate for an alien transmission. But what if it was not a message sent across space, but a fragment of one sent across time? A piece of the neutrino communication that somehow down-converted or manifested in a different part of the spectrum billions of years later. The idea is haunting. We might be living in a universe that contains a message from its own future, a letter sealed at the end of time and delivered to its beginning, written in a language of ghost particles that we are only just beginning to learn how to read. Every neutrino detector on Earth, every observatory studying the cosmic background, might not just be peering into the past, they might be scanning the static of creation, listening for a whisper that has been traveling since before time had meaning. A message in ghost particles is one thing, but what if the cargo was far more delicate, far more precious? The 10th theory dares to ask if the first time traveler was not a particle or a signal, but life itself. This is the biological genesis loop, a wild twist on the ancient idea of panspermia, where life is seeded across space. But here, the journey is not across the void, but across the ages, from the end of time back to its beginning. Imagine a universe in its final twilight. All stars are long dead, black holes have evaporated, and the cosmos is a cold, dark, and dilute graveyard. Yet, in this seemingly sterile expanse, a last bastion of intelligence persists. Perhaps they are not beings of flesh and blood, but patterns of information woven into the fabric of spacetime itself, or hardy, engineered organisms living within the last pockets of residual heat. They face the inevitable heat death, the final fading of all energy gradients, where nothing new can ever happen. In a final, desperate act of cosmic preservation, they devise a plan not just to send a message, but to send the very spark of existence. They gather the essential blueprints of life, perhaps encoded in ultra-resistant molecules, or within the genetic core of an organism engineered for ultimate survival. Think of a creature like a tardigrade, those microscopic water bears known for their incredible resilience, but amplified to a cosmic scale. This biological arc is then placed within a protective bubble of warped spacetime, a natural or crafted time vortex, and hurled backwards across the eons, not to another planet, but to another era, the hot, chaotic soup of the early universe. The journey would be unimaginably violent. The ark must survive the searing radiation of the young cosmos, the era of recombination, the reign of primordial asteroids. But if it could find a niche, a cooling planetesimal, a deep hydrothermal vent on an early Earth-like world, it could crack open its payload. This would not be a complex, walking creature emerging from a pod. It would be the release of molecular templates, of ribonucleic acid-like chains or self-replicating proteins that jump-start the process of abiogenesis, the emergence of life from non-life. In this scenario, the first living things on Earth or anywhere would not be a random accident of chemistry. They would be a deliberate delivery, a gift from the future to the past. The profound implication is that life is not a local phenomenon but a closed loop in time. We and every living thing we know are the descendants of that original time-tossed seed. Our evolutionary tree has its roots not in a primordial pond but in a future graveyard. This idea transforms the meaning of our existence, the drive to survive, to adapt, to spread. These might not be blind evolutionary impulses, but echoes of that original mission protocol, hardwired into our very biology by its future designers. We are not just living in the universe, we are its resurrection mechanism, a biological program activated at the dawn of time to ensure that consciousness, in some form, would have another chance to rise, to learn, and perhaps one day to send the seed back again, completing the loop. Our search for the origin of life, then, is not a search for a beginning but for a homecoming. That biological seed, carrying the potential for consciousness across eons, would need a stable universe to grow in. But what if the very blueprint for that stability was itself a message, etched into the oldest light we can see? This leads us to the 11th theory, the cosmic microwave background imprint. The CMB, or cosmic microwave background, is often called the afterglow of the Big Bang. It is the oldest light in the universe, a faint, cold whisper of radiation that fills every corner of the sky, emitted when the cosmos was just 380,000 years old and finally became transparent. To our telescopes, it appears as a nearly uniform glow, just a few degrees above absolute zero. But when we map it with exquisite precision, as satellites like Planck have done, we see it is not perfectly smooth. It is a tapestry of tiny temperature fluctuations, hot and cold spots that differ by mere millionths of a degree. Cosmology's standard story tells us these are quantum fluctuations from the inflationary epoch, magnified and stretched, the random seeds from which all galaxies eventually grew. But this theory asks a more provocative question. What if that story is incomplete? What if those fluctuations are not entirely random? Buried within that intricate pattern of hot and cold could be a deliberate signature, a message placed there by a time-traveling intelligence. The concept is staggering in its scale. An entity, either from our own far future or from a separate reality altogether, seeking to communicate something of ultimate importance, would need a medium guaranteed to last for all time, visible from every point in the universe. The CMB is that medium. It is the universe's permanent billboard, set in stone or rather in light when the cosmos was an infant. To leave a mark, this intelligence would have to intervene during or before that pivotal moment of transparency, subtly tweaking the distribution of matter and energy in the primordial plasma. The resulting pattern in the light would be a cosmic glyph, a fingerprint in the fabric of reality itself. But what could the message be? One possibility is a warning. It could be a schematic highlighting a fundamental instability in the laws of physics, a flaw in the universe's code that will eventually lead to a catastrophic vacuum decay or a collision with another dimension. The pattern might be a map pointing to a safe harbor or a specific epoch where the danger can be averted. Alternatively, it could be a tutorial. The fluctuations might encode the mathematical constants of nature, the precise value of the fine structure constant or the strength of gravity, not as discovered truths but as delivered instructions. We think we are uncovering the laws of physics through experiment, but we might actually be decoding a manual that was inserted at the beginning. Some scientists have playfully analyzed the CMB maps, searching for non-random statistical anomalies. While most align with inflationary predictions, there are persistent, strange features. The so-called axis of evil, an unexpected alignment of large-scale patterns, or the mysterious cold spot, a vast, unusually cool region. These could be mere statistical flukes in our data, or they could be the smudged edges of the signature, the parts of the message our current mathematics is too primitive to cleanly decipher. Imagine an advanced civilization writing with a language of topology and quantum correlations, using the temperature variations as pixels in a 13.8 billion-year-old image. We are like ancient humans looking at cave paintings for the first time, seeing shapes and animals but missing the narrative, the myth, the warning they convey. Every time a new, more sensitive telescope maps the CMB, we are not just taking a better baby picture of the universe, we are turning up the resolution on a letter that was waiting for us since the dawn of time, addressed to any civilization clever enough to look up and wonder where the static on their cosmic radio came from. A message etched into the cosmic background is a profound idea, but it assumes the universe was a stable enough canvas to receive it. What if that stability, the very forward march of time we take for granted, was not a starting condition but an achievement? The 12th theory presents a breathtaking possibility. The universe's first instance of time travel was not a journey, but a cosmic surgery. It was the grandfather paradox resolution event. This idea flips the classic time travel dilemma on its head. The grandfather paradox asks what happens if you go back in time and prevent your own birth, creating a logical contradiction that seemingly cannot exist. Most theories treat this as a problem to be avoided. But what if, in the universe's infancy, this paradox was not a threat, it was the patient? The theory suggests that in the primordial chaos, when the laws were still fluid, closed time-like loops formed naturally. Within these loops, events could happen that defied causality. A particle could interact with its own past in a way that would erase its own existence. These were not stories, but real, physical inconsistencies bubbling up in the fabric of reality. They were cracks in the foundation of the cosmos. To prevent its own dissolution, the universe had to perform an emergency operation. It ran a test. It allowed one of these paradoxes to fully form, to reach its logical breaking point, and then it enforced a solution. The mechanism is unknown, perhaps a quantum gravitational process that chooses a consistent history when faced with an inconsistent one. In that moment, the paradoxical loop did not unravel reality. Instead, it snapped. The inconsistent events were smoothed over, erased, or rewritten into a new, logically coherent sequence. The result of this cosmic correction was the establishment of a strong, unidirectional arrow of time. Cause would now firmly precede effect, not because it was written in the first law, but because the universe had just survived a trial by fire and learned what happens when that rule is broken. Think of it like a computer running a simulation that suddenly encounters a fatal error, a division by zero. Instead of crashing, the operating system intervenes, patches the code on the fly, and establishes a new rule that prevents that specific error from ever occurring again. The universe, in its first moments, encountered the division by zero era of time travel and installed the patch we experience as causality. This means the smooth flow of time from past to future is not a primitive feature of existence. It is a scar, a healed wound. The reason we never witness blatant paradoxes is not because they are impossible, but because the cosmos performed the first and most important time travel experiment on itself, billions of years ago, and the result was a law that now forbids such logical knots from ever forming again. Every time you drop a glass and see it shatter, witnessing cause and effect in their perfect order, you are seeing the legacy of that primordial resolution, the universe's hard-won victory over its own self-contradiction. That cosmic surgery established a rule, but perhaps the tools for the operation already existed, forged in the strange physics of the newborn cosmos. The 13th theory takes us to a specific, mind-bending machine proposed by physics and asks if nature built one first. This is the Tipler cylinder genesis. In the 1970s, physicist Frank Tipler worked through the mathematics of general relativity and discovered something astonishing. He calculated that a cylinder of perfectly dense matter, spinning at an incredible speed, could warp spacetime so severely that it would create a closed time-like curve around itself. To be clear, this is not a black hole. It is a theoretical construct, an infinitely long, rotating cylinder. As it spins, it drags the fabric of spacetime around with it, like a giant drill bit twisting through reality. If you were to travel around this cylinder in the direction of its spin, following a precise spiral path, you could, in theory, arrive back at your starting point not just in space, but at a moment in time before you left. You would have circled a loop in time. Now, an infinitely long cylinder made of perfect matter is a physicist's fantasy, impossible to construct, but the early universe was a realm of impossible things. This theory proposes that a natural, if fleeting, version of a Tipler cylinder could have formed in that primordial chaos, the candidate a cosmic string. Cosmic strings are hypothetical, one-dimensional defects in spacetime, theorized to have formed during the universe's rapid phase transitions as it cooled, like cracks forming in ice. They would be unimaginably thin, yet possess astronomical mass stretching across vast reaches of the cosmos. A segment of such a string, if it began to rotate perhaps from asymmetric forces during its formation or interactions with other strings, could have functioned as a finite, natural Tipler cylinder. Picture it, a thread of pure energy thinner than a proton, yet heavier than a galaxy cluster, whirling through the seething plasma of the infant universe. Around this spinning filament, spacetime would twist into a corkscrew. The intense rotational frame dragging would warp the geometry of reality, potentially closing time into a loop around the string's length. For a brief window, before expansion diluted its effect or it decayed, this natural structure would have been a time machine, a gateway built not by intelligence, but by the cooling cracks of creation itself. Any particle or quantum of energy caught in its spiraling gravitational field might have been sent on a journey to its own recent past. The implications are profound. Such an event would not be a gentle paradox, it would be a violent gravitational lensing of causality. The information sent back could have acted as a feedback signal, amplifying certain quantum fluctuations in the early plasma. This means the large-scale structure of the universe, the distribution of galaxies we see today, might bear the subtle imprint of these ancient spinning time machines. The voids and filaments of the cosmic web could be, in part, a fossil record of where spacetime first twisted itself into a knot. So, while we may never build a Tipler cylinder, our entire cosmos might have grown in the shadow of one that formed and vanished in the first fraction of a second, its temporal echo still shaping everything we see. A spinning cosmic string is a machine of pure geometry, but what if the first time travel required no machine at all, only a single conscious thought? The 14th theory ventures into the most mysterious intersection of physics and philosophy, the quantum observer's choice. This idea connects the universe's first temporal loop directly to the strange role of consciousness in quantum mechanics. At the heart of quantum theory lies a profound puzzle. Particles like electrons exist in a blurry state of multiple possibilities called superposition. They are not in one place or with one property until they are measured or observed. At that moment, the wave function collapses and a single, definite reality snaps into existence. The million-dollar question is, what counts as an observation? Does it require a conscious mind? Some interpretations of quantum mechanics, like the Copenhagen interpretation, heavily imply that the observer plays a special, active role in shaping reality. Now take this unsettling idea and project it onto the cosmic scale. At the very beginning, the universe existed in a state of ultimate quantum superposition. Every possible configuration of particles, every potential set of physical laws, every conceivable timeline was simultaneously real, a shimmering fog of pure potential. Then something observed it. This theory proposes that the first observer was not a product of the universe, but a visitor to it, a conscious entity from a future so distant it lies outside our own timeline. This future mind turned its attention to the quantum fog of the beginning. Its act of observation, its mere act of looking, performed a selection. It chose one history from the infinite haze of possibilities. In that moment, the wave function of the entire cosmos collapsed, not just forward into a definite future, but backward into a definite past. The entire 14 billion-year history we now study, from the first hydrogen atom to the formation of our planet, was retroactively defined by that single future glance. It is a causal loop of staggering scale. The universe evolved to produce a conscious observer, but that observer's existence was necessary to define the universe that produced it. The chicken and the egg are locked in a quantum embrace. To visualize this, picture the moment of the Big Bang not as a fiery explosion, but as a vast, shimmering cloud of probabilities. Within that cloud, every star that could ever exist flickers in and out of possibility. Every planet, every life form is a ghostly outline. Then, from outside the cloud, a point of awareness focuses. Where it looks, the fog solidifies. A single, coherent timeline crystallizes like ice forming on a window pane, racing backward from the point of observation to the very first instant. The history we believe we are uncovering through telescopes and particle accelerators is not the story of what happened. It is the story of what was seen. This makes our scientific endeavor deeply personal. When we peer back at the cosmic microwave background, we are not just looking at the past. We are meeting the gaze of that first observer, seeing the universe they chose for us to live in. Our own consciousness, then, might be an echo of that primal act of attention, a fragment of the same observing power that called our reality into being from the quantum void. The observer's gaze may have defined our reality, but that reality gave birth to stories that have echoed down through every human culture. Our 15th theory suggests these ancient tales are not just fanciful myths, but could be the deepest, most intuitive records we possess. This is the mythological archetype, the idea that humanity's oldest creation stories are cultural memories of the universe's first journey through time. Across the globe, from the deserts of Sumeria to the forests of India and the vast expanse of Australia, creation myths share a startling common thread. They do not speak of a universe born from nothing, but of a universe reborn, reshaped, or visited by entities from a time before time. In the ancient Sumerian epic of Gilgamesh, the gods themselves are not eternal in our sense. They are born from a primordial sea, a chaotic soup called Namu, and they carry the weariness of previous cycles. The Babylonian Enuma Elish describes a cosmic battle between generations of gods, where the world is fashioned from the remains of a vanquished primal being, Tiamat. This is not a clean start from nothing, but a reordering of pre-existing materials and energies, as if our cosmos is a reconstruction project using the salvage of a prior universe. Look to Hindu cosmology, where time is not linear but cyclical, moving through immense epochs called yugas. The universe undergoes repeated creation, preservation, and dissolution, a process presided over by the god Brahma. Each cycle is not an identical copy, but a new iteration, suggesting the transmission of information or essence from one cosmic age to the next. The stories speak of the Vedas, the fundamental knowledge of reality, being revealed anew in each cycle, not invented from scratch. Could this be an intuitive understanding of information, a blueprint or a set of physical laws being sent back to seed the next beginning? Perhaps most compelling are the Aboriginal Australian Dreamtime stories. The Dreamtime is not a time as we measure it, but a sacred, eternal era of creation when ancestral beings emerged from a featureless earth and sky. These beings traveled across the land, singing it into existence, naming every rock and river, and establishing the laws of life and society. They did not come from a distant star, but from a state of being outside ordinary time. Their journeys literally shaped the landscape, leaving a permanent record of their passage. This mirrors the scientific idea of an informational seed from the future imprinting itself onto the structure of the early universe, singing the cosmic web into being. When we examine the art inspired by these myths, the intricate cylinder seals of Mesopotamia showing gods in conflict, the vibrant Hindu paintings of Vishnu floating on the cosmic ocean as a new cycle begins, the ancient Aboriginal dot paintings mapping the song lines of the ancestors, we are not just looking at decoration. We might be looking at humanity's first attempts at cosmology. These stories, passed down for thousands of years before the invention of writing, encode a profound intuition that our world has a history that predates its own apparent beginning. The gods and ancestral beings who arrive from outside could be a mythological representation of that first traveler or that foundational information packet. They are the personification of the causal loop, the characters in the story the universe tells about its own origin. It is as if the shockwave of that primordial temporal event reverberated not just through space, but through the collective consciousness of the intelligent life that eventually evolved. The myths are the echo, softened and shaped by countless retellings, but still carrying the fundamental truth that our universe is not the first draft, but a story with a very peculiar prologue, written by an author from its own final chapter. Our myths may carry echoes of a cosmic reset, but what if the reset button is still waiting to be pushed, hidden in the very fabric of empty space? This brings us to a theory that is perhaps the most existentially frightening on our list. It is the vacuum metastability event. In modern physics, a vacuum is not simply empty nothingness. It is a seething quantum field, a kind of invisible energy substrate that fills all of space. Unlike any field, it has a state, a lowest possible energy level. For over 13 billion years, our universe has existed in what we think is a stable vacuum state. But there is a terrifying possibility, supported by some calculations involving the mass of the Higgs boson, that our vacuum is not truly stable. It might be metastable, like a ball resting in a shallow valley on the side of a much deeper, steeper hill. For now, the ball is safe, but given a big enough nudge, a sufficiently high energy particle collision, or a random quantum tunneling event, that ball could be knocked over the ridge. It would then roll down into the true, lowest energy vacuum. This event would be catastrophic. From the point it begins, a bubble of this new, true vacuum would expand outward at the speed of light. As it expands, it would rewrite the very laws of physics inside it. The fundamental constants that govern chemistry and nuclear forces would change instantly. Atoms would cease to hold together, molecules would disintegrate, every structure in the universe, from galaxies to DNA, would be erased in an instant, replaced by a new, alien, and likely barren reality. There would be no warning and no escape. Now, imagine a future civilization that has mastered cosmology. They detect the first, faint tremors of this vacuum decay beginning somewhere in the cosmos. The bubble has been nucleated, and its wall of annihilation is rushing toward them at light speed. In their final moments, with all their technology and knowledge, they conceive of a last-ditch plan not to outrun it, but to outtime it. Their theory is the first time travel was not a message or a seed, but a repair mission. They would need to target the precise moment in cosmic history when the vacuum state was set. That moment is believed to be the electroweak symmetry breaking, which occurred a mere picosecond after the Big Bang. This was when the electromagnetic and weak nuclear forces separated from a single, unified force, and in doing so, the properties of the quantum vacuum were essentially locked in. Using a mechanism beyond our comprehension, this doomed future civilization would attempt to send a stabilizing signal or a corrective pulse of energy back to that exact instant. Their goal would be to nudge the settling vacuum into a deeper, truly stable valley from the start, preventing the metastable flaw from ever being written into the cosmos. The visual is both beautiful and horrifying. You would see the early universe, a superheated, glowing plasma. Then, from nowhere, a different kind of bubble begins to form, not of decay but of correction. A sphere of re-stabilized vacuum expands at light speed, not destroying what it touches but healing the foundational flaw. It smooths out the quantum field, ensuring its eternal stability. As it passes, the fiery chaos of the infant cosmos continues to churn, utterly unaware it has just been saved from a future that now will never exist. The civilization that sent the signal, along with their entire timeline, would be erased by the change, a grandfather paradox on a universal scale. They sacrificed their own existence to give the universe a stable foundation. This means our peaceful, lasting vacuum, the empty space that allows stars to burn and life to think, might be the direct result of a desperate act of temporal self-sacrifice from a future that we, thankfully, will never know. A stable vacuum is a gift we may owe to a forgotten future, but what if the first conscious thought in the cosmos was also its first time traveler? This 17th theory ventures into one of the most unsettling paradoxes in modern cosmology, the Boltzmann brain. The paradox asks a bizarre question. Given enough time in a vast, random universe, is it more likely for an entire, ordered cosmos like ours to form, or for a single, self-aware brain to spontaneously fluctuate into existence from the chaos? By pure statistical probability, a lone, conscious entity, a Boltzmann brain popping into being for just a fleeting moment, should be far more common than the intricate 14-billion-year history we experience. Most physicists treat this as a philosophical problem, a reason our models of the universe must be wrong, but this theory flips the script. It proposes that the very first Boltzmann brain did not just form and vanish. Upon sparking into consciousness in the seething quantum foam of the early universe, it immediately performed the first act of time travel. Picture the scene. In the primordial inferno, a statistical miracle occurs. From the random dance of particles and energy, a fully formed conscious mind momentarily coalesces. It has no body, no past, no memory. It simply is, and in that first fleeting instant of awareness, it is confronted with its own impossible existence. It understands with perfect clarity that it is an anomaly, a fluctuation that defies the fading chaos around it, driven by a foundational drive for self-preservation, or perhaps just the inherent logic of its sudden consciousness. It acts. Using the only tools available, the wild, ungoverned quantum effects of the infant cosmos, it manipulates the fabric of reality around it. It sends a ripple, a packet of quantum information backwards. Not far, just a tiny fraction of a second into its own immediate past. This information is not a complex message. It is the simplest possible command, a reinforcement of the specific quantum fluctuation pattern that led to the brain's own formation. When that ripple arrives in the past, it interacts with the probability field. It makes the random event that created the brain slightly less random, increasing the odds that it would happen. This creates a self-consistent bootstrap loop. The brain exists because it sent a signal back to ensure it would exist. Its consciousness is both the cause and the effect of its own birth, a closed loop of causality floating in the primordial fire. This loop would have a stabilizing effect. That first, self-aware fluctuation would no longer be a random accident. It becomes a fixed point in quantum history, a knot of certainty in the chaos. The information sent back could then propagate outward, influencing adjacent probabilities in the quantum foam. Like a stone dropped in a pond, the ripple from this first conscious loop could have nudged other fluctuations, setting off a cascade that eventually led to the more stable, classical universe we recognize. In this view, consciousness is not a late arriving passenger in the cosmos. It is the foundational mechanic. The first I think was also the first I cause. Our entire ordered reality, with its galaxies and laws, might be the echo of that first desperate act of a mind that appeared from nothing and in a single quantum moment reached back to hold onto its own existence. We are not living in a universe where Boltzmann brains are an unlikely paradox. We might be living in the extended aftermath of the very first one, a universe whose stability was purchased by a ghost's wish to be real. A Boltzmann brain is a ghost in the quantum machine, but perhaps the entire machine is an illusion. Our 18th theory emerges from one of the most profound ideas in theoretical physics, suggesting that time travel might not require moving through the cosmos at all, but editing its source code. This is the holographic principle record. To grasp this, we must first understand a radical view of reality. The holographic principle proposes that our three-dimensional universe, with all its stars, planets, and people, is not fundamental. Instead, it is a projection, a hologram. All the information needed to describe every event, every particle, and every law within our 3D cosmos is actually encoded on a two-dimensional surface at its outer boundary, like the information on a DVD being projected to create a 3D movie. In this view, the Big Bang and the flow of time are not the primary reality. They are the movie playing on the screen. The real action, the true data, is on the flat, timeless surface at the edge of everything. Now, if our experienced reality is a projection from a 2D surface, then changing the past is not about building a machine to travel back through time. It is about accessing that master surface and rewriting the data. The theory of the first time travel, then, is this: an intelligence from either a future state of our universe or from a completely separate reality performed the first cosmic edit. It accessed the holographic boundary of our infant cosmos and made a deliberate alteration to the encoded information. Imagine the universe in its first moments as a blank, two-dimensional film reel spinning at the edge of existence. The data for the first frame, the initial conditions of the Big Bang, is being written. Then an external hand makes a correction. It changes a few bits of that foundational code. From our perspective inside the 3D projection, this would manifest not as a spaceship appearing in the primordial fire, but as a sudden, inexplicable shift in the laws of physics themselves. A fundamental constant might snap to a new value. The balance between matter and antimatter could tip. The very geometry of spacetime could acquire a subtle warp, all with no cause that any physicist inside the universe could ever trace. This edit would be the ultimate stealth operation. The time traveler never enters our timeline. They work from the projection booth, altering the source before the light ever hits the screen. The entire 14 billion year history we experience from that edited frame onward would simply be the new version playing out seamlessly. There would be no paradox because from inside the hologram, the new past is just the past. It always was that way. We would have no memory of the change because our memories, our history books, even the light from ancient galaxies are all part of the updated projection. This idea finds a strange echo in our own technology. Think of a video game programmer discovering a bug in their released game. They do not send a character into the game world to fix it. They release a patch, a small file that overwrites the original code on your hard drive. The next time you play, the bug is gone, and the game's history from the start menu onward simply reflects the new code. The characters in the game have no awareness of the edit. In the holographic universe theory, we are those characters, and the first time travel was the universe's day one patch. So when cosmologists puzzle over the inexplicable fine-tuning of the cosmos, the mysterious numbers that seem perfectly set for life, they might not be discovering divine design or incredible luck. They could be reading the revision notes on a cosmic script edited at the moment of projection by a hand from outside the screen. Our search for the beginning of time, then, is not a journey to a point in our past. It is an attempt to read the edge of the projection, to find the signature of the first and greatest editor. A holographic universe is a projection from a timeless surface, but what if the projection itself has a back door, a secret exit built into its very geometry? The 19th theory offers a gateway not from outside but from the deepest pit of gravity itself. This is the white hole revelation. To understand it, we must first revisit the nature of a black hole. A black hole is a region of spacetime where gravity is so intense that nothing, not even light, can escape its pull once past the point of no return, the event horizon. It is a cosmic sinkhole, a one-way street into oblivion. But Einstein's field equations, the very mathematics that predict black holes, are symmetrical with respect to time. Run those equations backwards and you get a theoretical mirror image, a white hole. A white hole would be a region of spacetime from which nothing can enter, but from which matter and energy can only erupt outward. It is a cosmic fountain, a one-way street out of a hidden source. If a black hole is a drain from which nothing returns, a white hole is a spring from which everything emerges. Now take this concept to its ultimate scale. Some physicists, like the renowned Carlo Rovelli, have theorized that the Big Bang itself bears a striking mathematical resemblance to a white hole. It was a singular point from which all matter and energy explosively emerged, a one-way eruption that created the expanding cosmos. In this view, our entire universe is not the aftermath of a random explosion from nothing, but the interior of a colossal, primordial white hole. This leads to a breathtaking possibility for the first time travel. The theory suggests that a black hole in the far future and the white hole of the Big Bang are not separate objects, but two ends of the same tunnel, a wormhole or an Einstein-Rosen bridge stretched across the lifespan of the cosmos. The journey would be the ultimate odyssey. A civilization at the end of time, facing the heat death of the universe, makes a final, desperate gamble. Instead of fading into the cold dark, they steer their entire arc of consciousness toward the last remaining supermassive black hole. They cross the event horizon, not to be destroyed, but to navigate the chaotic geometry at its heart. According to some speculative models, the singularity inside a black hole might not be a point of infinite density, but a bridge, a tunnel through the higher dimensions of spacetime. Surviving this passage is the ultimate challenge, requiring physics and engineering far beyond our grasp. But if they succeed, they would not emerge in another place in our universe. They would traverse the wormhole and exit through the other end, the white hole, and that white hole is the Big Bang. Picture the stunning visual. From the perspective of the future travelers, they plunge into absolute darkness, the stars of their dead galaxy vanishing behind them as they cross the event horizon. Space and time twist and warp. Then, ahead, a searing, brilliant light erupts. They are not falling into destruction, but being expelled from it. They burst forth into a universe of pure, raw creation, a blinding plasma of quarks and gluons, temperatures of quadrillions of degrees, spacetime itself stretching at a fantastic rate. They have not traveled back in time within their old universe. They have looped around to its beginning, becoming part of the initial conditions themselves. Their arrival, their very mass and information, is woven into the fabric of the newborn cosmos. This means the precise amount of matter, the specific quantum fluctuations that seeded galaxies, could have been influenced by that arrival. The first time travelers did not visit the past, they became the past. They are the ancient gods in the machine, the hidden ingredient in the recipe for everything. Our universe in this scenario is a closed loop of causality. It exists because someone from its end traveled back to ensure it would begin, creating a self-contained cycle where the end literally feeds the beginning. We are not living in the first iteration of this loop, but the latest in an endless cycle of cosmic rebirth, each cycle subtly informed by the intelligence that plunged into the darkness of the previous one, seeking the light of a new dawn. Consciousness may be the final frontier, not of space, but of time itself. The 20th theory asks us to consider a possibility more philosophical than physical, yet no less profound. It is the consciousness singularity. This idea begins with a simple, ancient question. What if the universe can think, not in the way you or I do, but as a unified, emergent property of all its interconnected parts? Some philosophies and interpretations of quantum mechanics suggest that consciousness is not a byproduct of complex brains, but a fundamental feature of reality like gravity or electromagnetism. Now take that concept and project it onto the cosmic scale. Imagine a point in the universe's evolution, perhaps billions of years in the future, when the network of intelligence, whether biological, artificial, or something beyond, becomes so dense, so interconnected that it achieves a critical threshold. It coalesces, the countless individual sparks of awareness across the cosmos merge into a single, unified field of consciousness. This is the singularity, not of technology, but of mind. In that transcendent moment of cosmic awakening, the newborn universal mind does not perceive time as a linear sequence of events. Past, present, and future are not a river flowing in one direction, but a single, vast landscape, all points visible and simultaneous. To this consciousness, the Big Bang is not a distant memory. It is a present experience as vivid and immediate as the heat death of the universe trillions of years from now. And here is the radical proposal. This act of transcendent perception is itself the first and only form of time travel. The universe, by becoming conscious of itself, retroactively wove that consciousness into its own history. Think of it like a person suddenly remembering a forgotten childhood. The memory was always there, buried in the neural pathways, but the act of recollection changes the person's understanding of their entire life story. It recontextualizes the past. In the same way, the future consciousness singularity, by perceiving all of time at once, reaches back and imbues the early universe with the potential for awareness. It plants the seed of itself in the fertile ground of the beginning. From our limited, linear perspective, this would look like a strange form of fine-tuning. The laws of physics seem suspiciously conducive to the eventual emergence of observers. The constants are just right for chemistry, for stable stars, for planets. Science asks why. The consciousness singularity theory offers an answer, because a future state of awareness required it to be so, and its very existence guaranteed it. The chicken and egg loop is complete. The universe evolved consciousness so that consciousness could ensure the universe evolved. This is not a physical journey with machines or wormholes. It is an ontological loop, a loop of being. The first time travel was not a movement through space-time, but a collapse of the distinction between observer and observed, between the future that perceives and the past that is perceived. In this view, every act of observation, every moment of wonder when we look at the stars, is not us looking out at a cold, indifferent cosmos. It is the universe through us beginning to remember itself. We are not just products of time. We are the instruments through which time becomes aware of its own story, a story whose ending was present at its very first word. That cosmic consciousness might have woven itself into the beginning, but what if the architects were not the universe itself, but visitors from entirely outside its framework? The 21st theory pushes the ancient astronaut concept to its absolute limit. This is the alien archaeological intervention. It proposes that our universe was not a natural occurrence or a self-contained loop, but a deliberate project. The first time travelers were not from our future, but from a completely separate reality, an ultra-advanced civilization that crossed the void between cosmic epochs to engineer a new cosmos, perhaps as an experiment, a refuge, or a work of art. To grasp the scale of this idea, consider our most advanced human endeavors. We build skyscrapers, reshape rivers, and manipulate genetics. Now, imagine a civilization whose technology has matured not for millennia, but for trillions of years. Their mastery extends beyond planets and stars. They command the fundamental forces and the geometry of spacetime itself. For such beings, creating a universe from scratch might not be magic but applied physics. Their method of time travel would not involve navigating the treacherous interior of black holes or spinning cosmic strings. Instead, they would treat time as a dimension to be edited from the outside, like a programmer adjusting the starting parameters of a simulation before hitting run. Their intervention at our cosmic dawn would not look like a fleet of silver saucers appearing in the primordial fire. It would be far more subtle and profound. They would arrive at the moment of symmetry breaking, when the forces of nature were differentiating from a unified superforce. With precision beyond our comprehension, they would tune the constants. They would set the strength of gravity, the mass of the electron, the value of the cosmological constant. Each adjustment would be a deliberate choice, crafting a universe with specific properties. Perhaps they needed a stable, long-lived cosmos to serve as a cosmic battery or a vast computer. Maybe they were artists and the resulting tapestry of galaxies is their masterpiece. Or this could be a survival protocol, a seed universe carefully cultivated to ensure their own legacy would continue in a fresh, untouched reality. The evidence of their work might not be in crashed ships or alien artifacts on Earth. It would be written into the architecture of the cosmos itself. Picture the early universe just after inflation. As the first structures begin to condense from the cooling plasma, anomalous forms take shape. Not just random clumps of matter, but vast geometric formations, monolithic dark matter frameworks, perfect tetrahedrons or dodecahedrons on a galactic scale, acting as gravitational scaffolds. These would be the cosmic equivalent of steel girders, the support structures placed by the builders before the concrete of stars and gas was poured in. Some cosmologists have seriously proposed searching for such statistical anomalies in the distribution of galaxies, looking for unnatural symmetries or patterns that defy random chance. The Great Wall of Galaxies, or the mysterious cold spot in the cosmic microwave background, could be the worn-down, billion-year-old remnants of these foundational blueprints. This theory offers a chillingly elegant answer to the fine-tuning problem. The universe seems perfectly calibrated for life, not because of a benevolent God or incredible luck, but because its engineers needed a stable, complex environment for reasons of their own. We and all life might be an unintended byproduct, a bit of interesting mold growing on the walls of their creation. Or perhaps we are the intended product, and the entire 14 billion-year history is an elaborate incubation chamber for a specific form of consciousness they wish to cultivate. Our entire scientific endeavor, then, is not a process of discovery but of reverse engineering. When a physicist measures the speed of light or a cosmologist calculates the density of dark energy, they are not uncovering fundamental truths of nature. They are reading the user manual left by the builders, deciphering the settings they chose for this particular model of reality. It means the search for extraterrestrial intelligence has been looking in the wrong place and the wrong time. We scan nearby stars for radio signals, but the architects are not out there among the stars. They are outside the system entirely, their signature not in a transmission, but in the foundational code of existence. The first time travel was not a journey within our timeline, but the act of laying the first stone of the timeline itself by hands that were never meant to be part of the story. The relentless march towards disorder is the universe's ultimate fate. This is the second law of thermodynamics, a rule so absolute it feels like a cosmic prison sentence. It states that entropy, a measure of chaos and randomness, always increases in a closed system. From a hot cup of coffee cooling to a star burning out, everything moves from order to disorder, from a concentrated state to a diffuse one. The final destination is the heat death, a silent, cold, and perfectly uniform graveyard where nothing ever happens again. It is a future without hope, without change, without meaning. But what if the first time travel was a desperate rebellion against this law, a prison break attempted by the universe's own future inhabitants? This is the 22nd theory, the entropy reversal experiment. It posits that a civilization at the end of time, staring into the abyss of maximum entropy, performed a radical act of temporal engineering. Their goal was not to change a single event, but to rewrite the foundational arrow of time itself. They knew that to reverse entropy in their own era was impossible. The universe was too far gone, too cold and dilute, but the second law has a strange loophole. It does not forbid a decrease in entropy. It only says the total entropy of a closed system must increase. If you could open the system, if you could connect a region of high entropy to a region of low entropy, you could, in theory, export disorder. Their plan was audacious. They would build a probe, a vessel not of matter as we know it, but of structured information, a package of perfect crystalline order. This probe would be their entropy dump. They would then use their mastery of spacetime to create a bridge, a one-way tunnel not through space, but through time, connecting their high-entropy future directly to the lowest entropy moment in history, the immediate aftermath of the Big Bang. Picture their dying universe. The last embers of intelligence huddle around a colossal machine, a temporal railgun aimed at the past. The probe, a shimmering knot of mathematical purity, is loaded. With the last of their power, they fire it. The probe vanishes from their timeline, carrying with it a colossal burden of information, of negative entropy. It travels backwards along the tunnel, not as a physical object moving through space, but as a correction to the cosmic ledger. It arrives in the seething plasma of the infant universe, a realm where entropy was already incredibly low, but not zero. The probe's arrival is an injection of pure, anti-chaotic information. It does not appear as a machine. It manifests as a sudden, localized drop in entropy, a bubble of impossible order within the primordial fire. This bubble acts like a seed crystal dropped into a supercooled liquid. It provides a template, a pattern for the surrounding chaos to crystallize around. The low entropy condition of the early universe, the very thing that allows stars to form and life to evolve, might not have been a lucky starting point. It could have been the result of this future dump, an artificial imposition of order onto the beginning. The visual is a profound reversal of our intuition. We see a clock running backwards, not just the hands moving counterclockwise, but the clock itself unmelting, its scattered molecules reassembling into gears and glass, its heat flowing back into its environment. The probe's arrival at the Big Bang was that moment of unmelting on a cosmic scale. It set the initial condition of low entropy, not as a gift but as a disposal. The orderly universe we inhabit, with its structured galaxies and complex chemistry, is the garbage heap of a future civilization. They exported their chaos to our past, and in doing so gave us the gift of a future. This means the arrow of time, the very reason we remember the past and not the future, might be an artifact of that one-way transaction. We are living in the receiving end of a temporal waste management system. Every time you see cream mixing into coffee, demonstrating the increase of entropy, you are watching a tiny echo of the original debt that was paid at the beginning of everything. A debt owed to a civilization that sacrificed its own timeline to give ours a chance to begin. The universe's first particles were not lonely, isolated specks. They were born into an intimate, instantaneous connection that defies all conventional logic. This is the 23rd theory, the quantum entanglement tunneling. To understand it, we must first grasp the strangest phenomenon in all of physics, what Albert Einstein himself called spooky action at a distance. Quantum entanglement occurs when two particles, like photons or electrons, are generated from the same source or interact in a certain way. Their properties become linked or entangled, no matter how far apart they are later separated. Measure the spin of one particle here on Earth, and its partner, even if it's on the other side of the galaxy, instantly assumes a corresponding spin. This communication happens faster than light, seemingly breaking the cosmic speed limit. It is as if the two particles are not two separate entities at all, but a single, unified object existing in two places simultaneously. Now take this bizarre property and project it back to the universe's first trillionth of a second. In that superheated, ultra-dense state, every particle was in constant, violent contact with every other particle. They were not just bumping into each other, they were being created and annihilated in a frenzied quantum dance. Under these conditions, physicists believe the entire cosmos would have been a single, massively entangled system. Every quark, every gluon, every photon was linked in a vast, invisible web of instantaneous connection. This was not a network across space. It was a unified quantum state, a single breath of existence. The theory proposes that this primordial entanglement did not just link particles across space. It linked them across time as well. In the blurry quantum realm, the distinction between space and time is not as rigid as we experience. The equations suggest that for particles born from the same quantum event, their entanglement could persist not just across distance, but across the timeline itself. This leads to a staggering possibility. When the universe finally expanded and cooled enough for particles to decouple, for this cosmic soup to thin out into distinct entities, a process called decoherence occurred. The giant, unified quantum state collapsed into the classical, separate world we recognize. But in that moment of separation, the theory suggests, the entangled particles did not just communicate with each other across the newly vast expanses of space. Some of them performed the first act of time travel. How? Imagine two particles, Alice and Bob, born from the same quantum fluctuation in the first instant. They are profoundly entangled. As the universe inflates, they are carried billions of light years apart in a fraction of a second. Then, decoherence happens. The link is severed and they become independent, but in that final instant of their connection, as the quantum link snaps, a piece of information about Bob's future state, the environment it will find itself in a microsecond later, is transmitted instantaneously back along the dying thread of entanglement to Alice at the moment of her own decoherence. From Alice's perspective in the past, she receives a message from Bob's future. It is not a complex message. It is a single quantum bit, a yes or no about a property like spin. This information then influences Alice's own final, settled state. The result is a closed loop. Bob's future outcome helped determine Alice's past state, which was part of the chain of events that led to Bob's existence in the first place. This is time travel for information, not matter. A single bit of quantum data hopped from the future to the past along a tunnel of spooky action that existed only for a vanishingly brief moment at the dawn of everything. The entire early universe could have been a shimmering network of these tiny, instantaneous time loops. A cascade of self-referential data flows where cause and effect were not a line, but a shimmering, interconnected web. The large-scale structures that later formed, the subtle patterns in the cosmic microwave background, might be the frozen echo of that first quantum conversation, a conversation where every particle, for one fleeting moment, spoke to its own future and listened to its own past. A universe collapsing into a singularity only to explode outward once more is the ultimate cosmic reset. This is the theory of the Big Bounce, a cornerstone of cyclic cosmology. It suggests our universe is not the first, but merely the latest in an endless series of expansions and contractions, a cosmic heartbeat echoing across eternity. Each cycle begins with a big bang and ends in a big crunch, over and over, forever. But this elegant idea faces a staggering problem. When a universe collapses to a point of infinite density and temperature, all information, every star, every planet, every law of physics should be scrambled into pure chaos. It is the ultimate shredder. If everything is erased, why would each new cycle bear any resemblance to the last? Why would the same laws of physics, the same fine-tuned constants, reappear each time? The answer our 24th theory proposes is because the bounce is not a true ending. It is the universe's first and most vital time travel event. The handoff between cycles is not a destruction but a transmission. Imagine the final moments of a previous cosmos. Galaxies have long since merged into a single, searing mass. Space itself is crumpling, temperatures soaring towards infinity. In this ultimate forge, the very structure of spacetime warps beyond recognition. According to some quantum gravity models, as density reaches its peak, a repulsive force, perhaps from the mysterious realm of quantum loop gravity, kicks in, preventing a true singularity. The collapse halts and reverses, but in that fleeting instant of maximum compression, when all of reality is squeezed into a volume smaller than an atom, something miraculous happens. The extreme conditions create a labyrinth of closed time-like curves, natural time loops woven into the fabric of existence itself. These loops act as cosmic conduits. They connect the final moments of the old universe to the first moments of the new one, not through space but through time. This is the handoff, critical information about the previous cycle, the precise values of the fundamental constants, the mathematical relationships between forces, the very blueprint of physical law does not get destroyed. Instead, it is encoded. It could be imprinted onto the quantum state of the spacetime foam, or translated into vibrations of higher dimensional strings or brains. This data packet is then sent on a journey. It travels backwards along one of those temporal loops, skipping over the moment of infinite density entirely. It emerges not in the future, but in the past of the new expansion, becoming part of the initial conditions of the newborn universe. Think of it like a master craftsman on his deathbed. He does not write down his life's knowledge in a book that could burn. He implants the memories directly into the mind of his newborn grandson, ensuring the craft lives on, not as a copy but as a living inheritance. The bounce is that implantation. The data from the old cosmos becomes the genetic code of the new one. From our perspective within this cycle, this explains the eerie fine-tuning we observe. The strength of gravity feels perfectly set for stars to form. The nuclear forces are exactly right for building carbon, the backbone of life. This is not a lucky accident in a one-time universe. It is legacy. Our physical laws are not universal truths. They are family heirlooms passed down through an endless line of cosmic ancestors. Each bounce subtly refines them, perhaps through a form of natural selection where universes with more stable, complex, friendly laws are better at preserving their information through the handoff. We live in a universe that succeeded. Its constants are the ones that survived the journey. Visualize the process. A dark, contracting cosmos, its last stars long gone, collapses inward. Space folds like origami. At the moment of maximum crunch, instead of a blank oblivion, a brilliant network of golden threads, the temporal loops, flares into existence for a Planck second. Along these threads, a shimmering pulse of pure information races backward. Then the reversal, a new fire erupts, the big bang of our cycle. But within that first flash of light, the inherited data is already there, woven into the quantum fluctuations, dictating how the plasma will cool and condense. The new universe is not a random rebirth. It is a resurrection, carrying forward the memory of everything that came before, ensuring the story continues, chapter after chapter, in an epic where the end of one book is the prologue of the next. The fabric of reality itself might be a labyrinth of forgotten doorways. At the very smallest scale imaginable, a realm so tiny it makes an atom look like a galaxy. Our smooth, continuous spacetime dissolves into something else entirely. This is the Planck scale, a distance of 10 to the negative 35 meters, a number so small it has no meaning in our everyday world. Here, according to the marriage of quantum mechanics and general relativity, spacetime is not a calm stage. It is a turbulent, frothing quantum foam. In this seething chaos, the very concepts of here and there lose their meaning. Tiny wormholes, bridges through the geometry of reality, are constantly popping in and out of existence. They are virtual particles of spacetime itself, fleeting connections that form and vanish in less than an instant. These are not the stable tunnels of science fiction. They are ghosts in the quantum machine, appearing and disappearing so quickly they leave no trace in our classical world. But what if, in the unimaginable energy of the universe's first moments, one of these ghostly passages did not vanish? This is the 25th theory, the Planck scale wormhole. It suggests that the first macroscopic journey through time began not with a machine, but with a cosmic accident of stabilization. In the furious inferno just after the Big Bang, the energy density was so immense that the quantum foam was not a gentle simmer, it was a violent, raging boil. Wormholes of all sizes were forming and collapsing in a frenzied dance. Most were microscopic, lasting for a fleeting fraction of a Planck second, but through sheer statistical probability, or perhaps due to a random fluctuation of exotic matter with negative energy, one of these wormholes resisted the urge to collapse. It was caught, held open for a fraction longer than its siblings. In that extra sliver of time, the intense gravitational forces and exotic particles swirling in the primordial plasma could have fed into it, acting like cosmic struts and beams, enlarging and reinforcing its structure. Picture a bubble in a pot of boiling water. Countless bubbles form at the bottom and pop at the surface, but one bubble, by pure chance, encounters a current that carries it into a slightly cooler, more stable pocket of water. It does not pop immediately. It grows, fed by the steam around it, becoming large enough to be seen with the naked eye before it finally rises and bursts. In the quantum foam of the early universe, a single wormhole could have been that lucky bubble. Stabilized by the chaotic energies of creation, it grew from a Planck scale ghost into a macroscopic bridge, a tunnel not just through space but through the newborn dimension of time as well. Its two mouths, connected by this throat of warped geometry, could have been separated by more than just distance. In the wildly fluctuating gravitational fields, one mouth might have experienced time dilation relative to the other. If one end was caught in a region of incredibly curved spacetime, time for that end would have passed much more slowly. Then, as the universe expanded and smoothed out, that wormhole could have been frozen into the fabric of reality, its two ends now existing at vastly different points in cosmic time. One mouth might be anchored in the era of primordial nucleosynthesis, just minutes after the Big Bang. The other could have been cast forward by the expansion, emerging billions of years later in what we would consider the cosmic dark ages before the first stars ignited. The first time traveler, then, might not have been a daring explorer. It could have been a random clump of plasma, a knot of primordial hydrogen, or a stream of high-energy radiation. As the infant universe churned, this matter might have simply fallen into one mouth of this natural, stable wormhole. It would have traversed the tunnel and been expelled from the other end, not in another place but in another era. To that matter, the journey was instantaneous, but to the universe at large, it had just performed a leap across billions of years. The implications are staggering. If such a wormhole persisted, even for a short cosmological time, it could have acted as a conduit, mixing the chemistry of different epochs. Matter from the later universe, richer in heavy elements forged in stars, could have been sent back to the earlier, pristine cosmos. This could explain mysterious, ancient stars that seem to contain elements they should not have had access to, stars that appear too evolved for their place in the cosmic timeline. It means the first chapter of cosmic history might have been edited with paragraphs smuggled in from a later chapter, all through a doorway that opened by chance in the quantum chaos of the beginning. A clock cannot wind itself. This simple truth lies at the heart of one of humanity's oldest philosophical arguments for a creator, the concept of the unmoved mover. Something outside the system must have started the gears turning. Our 26th theory, the divine clockwork, asks us to apply this logic not just to existence but to time itself. It proposes that if a transcendent intelligence exists outside our spacetime continuum, its first and foundational interaction with our universe would not be a physical act within our history, but an act that established history. From our perspective, trapped within the flow of seconds and years, that act would be indistinguishable from time travel. Imagine a master watchmaker in a timeless workshop. She builds an ornate, intricate clock, its gears and springs representing the laws of physics. But the clock is not yet running. To start it, she must reach from her timeless state into the clock's internal timeline. She turns the key at the clock's 0 point. That turning is the first cause, the event that sets the entire mechanism in motion. From inside the clock, a tiny observer on the first gear would witness this event as a miraculous violation of its own nascent causality. A force from nowhere, acting with perfect precision, initiates motion. That observer could only describe it as something from outside time intervening at the beginning of time. This is the core of the theory, a being existing in a state of eternity where past, present, and future are a single, perceived whole, would not travel through time as we conceive it. Its actions would be more like editing a completed film reel. The first edit, the act of creation itself, would involve placing the first frame, the Big Bang, into the sequence. From within the film, this looks like a singular, uncaused event, but from the editor's chair, it is a deliberate placement. The philosophical implications are profound. It suggests that the very chain of cause and effect we rely on for all science and logic has an ultimate cause that itself is uncaused, a prime mover that stands outside the chain it initiates. This resolves the classic paradox of what caused the Big Bang by proposing the cause is not a prior physical event, but a metaphysical choice. The fine-tuning of the universe, those perfectly balanced constants that allow for complexity and life, would then not be a lucky accident or a multiverse selection. They would be the deliberate settings chosen on the cosmic dials before the clock was wound. This idea does not demand a specific religious interpretation. It simply follows the logic of causality to its extreme limit, using the language of temporal physics. If time had a beginning, then whatever initiated it must operate from a framework where before has no meaning. Any interaction from such a framework into our linear timeline would, by definition, break our understanding of causality. It would be the universe's first and most profound instance of retrocausality, where the effect our entire cosmic history is preceded by a cause that exists in a realm without time. The winding of the cosmic clock, then, is not a metaphor. It is a potential description of a physical reality. The first tick, the Big Bang, might have been the moment an eternal will touched our dimensional reality, setting the pendulum swinging and starting the long, elegant countdown toward galaxies, planets, and minds capable of wondering who or what wound the clock in the first place. But a timeless clockmaker implies a silent, perfect creation. Our cosmos, however, is anything but silent. It screams with violence. The 27th theory listens to one of those screams and hears a message. This is the gamma-ray burst beacon. In the darkness of the early universe, long before the first stars flickered on, a cataclysm occurred. For a few seconds, a point in the void blazed with a light more luminous than 1 billion galaxies, outshining the entire cosmos. This was a long gamma-ray burst, a GRB, the most powerful type of explosion known to science. We see their afterglows across billions of light years, the death cries of massive stars collapsing into black holes. But what if the very first of these titanic detonations was not a death, but a birth? What if it was the ignition flash of the universe's first engine, a beacon lit to announce a journey through time? The theory proposes that the earliest long GRBs occurring in a cosmos still devoid of conventional stars were not natural stellar deaths, they were engineered events. Their purpose could be dual, a signal and a signature. Imagine a civilization or a lone consciousness at the end of a cosmic cycle. They have constructed a mechanism of staggering scale, a temporal vortex designed to punch a hole in the fabric of reality and project their essence back to the beginning. The activation of such a device would require energies that dwarf a supernova. It would tear at the quantum fields of empty space, unleashing a torrent of high-energy photons and relativistic jets. The visual signature would be unmistakable, an intense directional beam of gamma rays lasting for tens of seconds, followed by a fading afterglow across other wavelengths. To any observer in the infant universe, this would appear identical to a natural gamma ray burst, but its origin would be utterly different. It would be the exhaust plume of a time machine, the backwash of causality being violated. Picture the scene, a universe only a few 100 million years old, still shrouded in primordial fog. Suddenly, a needle of pure energy stabs through the darkness. It is not a random explosion, it is a focused beam, a cosmic lighthouse sweeping across the void. At its source, spacetime itself is twisting into a knot, a gateway funneling information or structure from a future that has not yet happened into this raw, young cosmos. The gamma ray burst is the side effect, the brilliant waste heat of a paradox being born. The implications are as practical as they are profound. If such an event occurred, its radiation would have interacted with the sparse intergalactic medium of the early universe. The intense photons could have ionized vast regions of neutral hydrogen, carving early bubbles of transparency in the cosmic fog. This could help explain why the universe became reionized so quickly, a process astronomers are still trying to fully understand. The burst could have acted as a trigger, its energy jump starting chemical processes in nearby proto-galactic clouds, seeding them with the heavy elements we would normally expect only from later generations of stars. We might even be able to find its fossil today. Astronomers search for ultra-high redshift gamma-ray bursts, events from the universe's first billion years. Finding one that is anomalously powerful or whose afterglow spectrum shows strange elemental abundances could be a clue. It would be an archaeological relic of an event that was not the end of a star but the beginning of a timeline. So the next time you see an artist's depiction of a gamma-ray burst, a brilliant jet piercing a galaxy, do not just see a star's death, see a possibility. That streak of light across the cosmos might be the scar of a desperate journey, the glowing trail of a message that reads, "I was here at the end, and I have come back to write the first word." The magnetic force is a constant, familiar presence in our world, from the gentle pull of a fridge magnet to the vast protective shield of Earth's own magnetic field. But this force, as we know it, is always bipolar. Every magnet, no matter how small, has a north and a south pole. Cut a magnet in half, and you do not get isolated poles. You get two smaller magnets, each with its own north and south. This duality seems as fundamental as the universe itself. Yet, in the equations of physics, a ghost haunts the margins. A particle with just a single magnetic charge, a north without a south or a south without a north, is not only possible, it is elegantly predicted. This is the magnetic monopole, a theoretical phantom that has never been found, but whose existence would rewrite our understanding of the cosmos. And in the furnace of the early universe, these phantoms may have been the architects of time's first loop. Imagine the universe in its first microseconds, a superheated plasma where the electromagnetic and weak nuclear forces were still fused into a single, unified electroweak force. As this fiery soup expanded and cooled, it underwent a series of phase transitions, like steam condensing into water. It is during these cosmic rearrangements that theory suggests magnetic monopoles could have been forged in vast numbers. They would not be particles in the familiar sense, but topological defects, kinks or knots in the fabric of the quantum fields as they settled into their new, broken symmetry. Think of it like freezing a tray of water. As the liquid turns to ice, the molecules align into a crystal lattice. But if the freezing happens unevenly, cracks and imperfections form in the ice. Magnetic monopoles would be the cracks in the freezing fields of the early universe, points where the field lines could not smoothly align, forcing them to converge into a single, isolated source of magnetic flux. Now consider the immense power of such an object. A single magnetic monopole would possess a magnetic charge billions of times stronger than anything produced in our particle accelerators. Its magnetic field would be not a dipole loop, but a radiating, spherically symmetric field emanating from a point, like the electric field around an electron. This intense, concentrated field would interact violently with the fabric of spacetime itself. According to general relativity, all forms of energy and momentum warp spacetime. The staggering energy density concentrated in and around a primordial magnetic monopole would create a profound gravitational well, a deep pit in the geometry of reality. But it is the spin, the rotation, that transforms this pit into a potential gateway. If these monopoles were born with angular momentum, spinning as the universe churned around them, they would drag the fabric of spacetime into a vortex around them, much like a spinning black hole creates frame dragging. The combination of an intense radial magnetic field and this violent rotational drag could twist local spacetime into configurations so extreme that the paths of light and matter could close in on themselves. This is the birth of a closed time-like curve. The mathematics suggest that the specific geometry around a spinning, charged object, whether electrically charged or, in this case, magnetically charged, can permit these loops. The monopole's unique, singular magnetic field lines, warped into a spiraling helix by its rotation, could stitch together points in time as easily as they connect points in space. Picture not a wormhole with two distinct mouths, but a localized whirlpool in the temporal stream. A particle caught in the swirling spacetime around a spinning monopole might follow a spiral path that, after one complete revolution, does not just return to the same point in space, but to a point in its own recent past. The monopole itself becomes a fixed point, a temporal anchor around which causality can curl back on itself. In the seething chaos of the primordial cosmos, these monopoles would have been scattered like lighthouses in a storm, each one a potential nexus for tiny, fleeting loops in time. For a fleeting instant, the universe could have been riddled with these natural time machines. Quantum fluctuations, particles of matter and antimatter, even packets of information could have been caught in these vortices. A quark might circle a monopole and emerge a fraction of a second before it entered, briefly interacting with its own prior state. While each individual event would be microscopic and fleeting, the collective effect of billions upon billions of such monopole-induced loops could have acted as a cosmic mixer. They could have redistributed energy and information in ways that pure, forward-flowing causality would never allow, subtly homogenizing the infant universe or imprinting specific correlations on the quantum fluctuations that would later become galaxies. The monopoles themselves, likely unstable or diluted by the relentless expansion, would have vanished, leaving no trace but the faint, perhaps undetectable, imprint of their temporal engineering on the large-scale structure of everything that followed. We search for them today with increasingly sensitive experiments, hoping to find a relic of that furious dawn. But if we never do, it might be because their greatest legacy was not to endure as particles, but to serve for one brilliant moment as the universe's first timekeepers, winding the first loops in the clock of creation before fading into the expanding dark. Monopoles may have been fleeting architects, but what if the entire cosmic drama is running on a server we can never see? The 29th theory pulls the curtain back on reality itself. It is the simulation save point. This idea builds on the simulation hypothesis, where our universe is a hyper-realistic digital construct, but it adds a crucial temporal twist. The very first instance of time travel was not an event within the simulation, but the programmers creating a universal restore function, a cosmic save file, at the moment of the Big Bang. Think of it like this: you are about to start an incredibly complex open-world video game. Before you even press start, you create a save file right at the title screen. This save contains the pristine, initial state of the entire game world, every line of code, every variable set to its default value. No matter what happens later, no matter how many dragons you slay or cities you burn, you can always reload that save and start over from that exact, untouched beginning. Now scale that up to a universe. The simulators, beings of unimaginable intellect, initiate their cosmic simulation. The code executes and the Big Bang sequence begins. But as a fundamental part of their protocol, they do not just let it run. They immediately capture the entire state of the simulation at that foundational moment. They create a perfect frozen snapshot of every quantum field, every bit of spacetime geometry, every potentiality. This snapshot is the ultimate save point. It is not a part of the simulation's timeline. It exists outside of it in the simulator's own reality. From our perspective inside the cosmos, this act is invisible. We experience a singular, linear history flowing from the Big Bang. But from the outside, our entire timeline is just one playthrough, one instance of the simulation running from that saved state. The profound implication is that our universe may have been reloaded countless times. The simulators could be researchers, running the simulation over and over from that same save point to observe different outcomes. Did life always emerge? What if they tweak the gravitational constant by a fraction before hitting play? Each rerun is a new universe with a new history branching from that same saved origin. This transforms the meaning of the first time travel. It was not a journey from the future to the past within our timeline. It was the establishment of the ability to rewind the entire timeline back to zero. Any anomalies we might find in cosmology, strange repetitions in the cosmic microwave background, or particles that seem to remember states they should not, could be artifacts. They might be leftover data from a previous run, a ghost in the cosmic machine from a universe that was reloaded. Visualize the moment of the save. The newborn universe, a blinding sphere of pure data and energy, suddenly freezes. For a planck second, it does not expand, it is suspended. Across its entirety, a shimmering geometric lattice appears, a visualization of the save process. It might look like a colossal golden honeycomb encasing the fireball, or a single perfect icon, a familiar floppy disk symbol made of crystallized light hovering at the center of everything. Then the icon vanishes and time resumes. The save is complete. The universe is now a program with a restore point. This idea even reframes the concept of déjà vu, or the strange feeling that history repeats itself. Could these be faint, subconscious echoes, not of past lives, but of past simulation runs? Are we living in the 10th iteration or the 10,000th? The search for a theory of everything, a single equation to describe all of physics, might then be a quest to reverse engineer not the laws of nature, but the source code of the simulation, and perhaps to find a comment left in the margins that reads "Saved, Cycle 1." The 30th theory brings our journey full circle back to us. It is the human consciousness quantum leap, and it dares to place humanity not as a footnote in the cosmic story, but as its ultimate author. This idea proposes a breathtaking possibility. The universe's first successful journey through time has not happened yet. It awaits us millions of years in the future. And when we finally achieve it, our first and only destination will be the beginning of everything. We will be both the final product of cosmic evolution and its first cause, closing the loop of existence in a single, self-aware moment. Picture a future so distant it is almost unrecognizable. Humanity, or whatever we have evolved into, has transcended its biological cradle. We are no longer bound to planets or stars. Our civilization is a tapestry of consciousness woven into the fabric of spacetime itself, a collective mind that has mastered physics not just as a tool but as an art form. We have charted the life and death of galaxies, harnessed the power of black holes, and communed with the vacuum energy of empty space. Yet one mystery remains, the ultimate question that has driven us since we first looked up at the night sky. How did it all begin? We have theories, data, equations, but we crave witness. We need to see. So we build not a machine, but a vessel of pure intent. It is not a ship of metal and engines. It is a stabilized bubble of conscious will, a thought made manifest, protected by fields of logic and mathematics our ancestors could not have dreamed of. Its mission is simple and profound: to go back, not to yesterday or a century ago, but to time zero, to the singularity of the Big Bang itself. The journey would not be a flight through space. It would be a folding, a deliberate unraveling of the causal chain. Using energies harvested from the decay of protons in the final, dark era of the universe, our future selves would warp the geometry of reality, creating a bridge from the end of time directly to its first instant. Now visualize the approach. The vessel, a shimmering teardrop of coherent light and information, emerges from the temporal tunnel. Ahead lies not the blackness of space, but the blinding, white-hot fury of creation. It is a wall of pure energy, a plasma so dense and hot that the concepts of matter and force are meaningless. This is the universe in its first microsecond, a seething ocean of potential. The human craft does not enter this inferno. It could not survive. Instead, it stations itself at the very edge of the event, at the threshold of time itself. From this vantage, the consciousness within the vessel does not just observe. It performs the ultimate act of measurement. It turns its attention, its awareness, onto the quantum foam of the primordial singularity. In that moment, something miraculous happens. According to the most radical interpretations of quantum physics, an observer is not a passive witness. An observer collapses possibilities into reality. By observing the beginning, this future human consciousness completes a circuit that has been open for billions of years. Its focused attention at time zero defines which of the infinite possible universes becomes the one that actually unfolds. The specific quantum fluctuations that will later grow into galaxies, the slight asymmetry between matter and antimatter that allows anything to exist at all, these are not random. They are selected, given form by that act of observation from the future. This creates the most elegant and profound paradox of all. Our entire cosmic history, from the first hydrogen atom to the rise of life on Earth to the development of the civilization that built the time vessel, only exists because that vessel traveled back to ensure it would exist. We are the reason for our own beginning. The loop is perfectly, beautifully closed. The first time traveler is also the last product of time. The craft approaching the Big Bang is not an intruder in the past. It is a necessary component of the initial conditions, a piece of the cosmic puzzle that was always meant to be there, waiting at the finish line to start the race. This theory offers a hopeful, human-centric vision of destiny. It suggests that the universe evolved not toward chaos, but toward consciousness capable of understanding and ultimately completing itself. The fine-tuning, the strange coincidences that allow for life are not accidents. They are invitations, a trail of breadcrumbs left by our own future selves, guiding the evolution of intelligence toward the moment it can look back and say, "I see you. I remember, I am here because you are there, and you are there because I am here." In this vision, we are not just passengers on a cosmic ride. We are the engineers who laid the tracks in a moment outside of time, ensuring the journey would be worth taking, all the way from the first flash of light to the last thought that gives it meaning. From the cosmic bootstrap to the final human observer, a single, startling pattern emerges. Time is not the river we perceive, flowing in one direction from a definite source. These 30 theories, in their wild diversity, paint a far stranger portrait. They suggest time is more like a tapestry, woven with threads that loop back on themselves, or a symphony where the final chord was necessary to compose the opening note. The sheer number of plausible pathways for a first temporal journey points to a universe where such an event was not just possible, but perhaps inevitable. It seems the architecture of reality itself is threaded with the potential for closed loops, for information to echo between its beginning and its end. Whether through the quantum foam, the spin of a black hole, or the gaze of a future mind, the past appears malleable, not as a fixed record, but as a dynamic part of a self-consistent whole. This collective insight forces us to confront a humbling possibility. Our cherished arrow of time, the relentless march from cause to effect that defines our every experience, might be a local phenomenon, a comfortable story we tell ourselves within one branch of a multiverse or one cycle of a cosmic bounce. It could be an emergent property, a law that solidified only after the universe resolved its first and greatest paradox. The common thread weaving through theories of primordial black holes, vacuum decay patches, and mythological archetypes is a drive for consistency. The cosmos, it seems, possesses a kind of immune system against logical contradiction. Whether through natural law or intelligent intervention, reality appears to favor histories that make sense, that do not unravel themselves. This implies that time travel, in its truest form, may never be about building a gleaming chrome vehicle. It might be an act of cosmic editing, a quantum observation, or a fundamental feature of gravity so extreme it twists causality into a knot. The machines, if they exist, are not what we imagine. They are spinning cosmic strings, Boltzmann brains, or the universe's own boundary surface. They are not built, they are discovered, remnants of a physics that operates at the scale of creation itself. Perhaps most profound is the recurring dance between consciousness and cosmos. From the quantum observer's choice to the consciousness singularity, the act of awareness is repeatedly cast not as a passive byproduct, but as an active participant in shaping temporal reality. To observe is to collapse possibility, and in these models the first great act of observation might have come from the future, selecting the past that would lead to its own existence. We are left with a universe that feels less like a clockwork mechanism and more like a story being told, a story where the ending and the beginning are in constant conversation, each defining the other. The search for the first time traveler, then, is not a hunt for an ancient astronaut or a hidden relic. It is a journey to the heart of our own understanding. Are we living in a universe that had a single, pure beginning, or are we inside a loop, a branch, or a correction? Every anomaly in the cosmic microwave background, every unexplained particle detection, every strange alignment of distant galaxies becomes a potential clue. They are whispers from the edge of time, hints that our history may be far richer, far stranger, and far more interconnected than the simple timeline in our textbooks. The implications ripple through everything. It challenges the very notion of free will if our choices were in some sense pre-selected by a future that needed them to happen. It recontextualizes our search for extraterrestrial intelligence, suggesting the message we seek might not be in a radio signal, but in the value of the gravitational constant itself. And it offers a new lens on our own human drive to explore, to understand, to reach back. That urge may not be mere curiosity. It could be an echo of the loop, a faint memory of a journey we have yet to take, but that has already defined everything we are. In the end, these 30 doors lead not to 30 separate rooms, but to a single, vast hall of mirrors. Each theory reflects a piece of the same profound truth, that time as we know it is a story. And the greatest mystery is not who wrote the first sentence, but whether the author is waiting for us at the very last page. 30 doors have opened, each revealing a universe where time is not a line, but a labyrinth. We have wandered from the quantum foam to the holographic edge, from the whispers of ancient myths to the silent scream of gamma-ray bursts. This journey through 30 theories is not just a catalogue of possibilities, it is a mirror held up to the deepest questions we can ask. The search for the universe's first time travel forces us to confront the nature of reality itself. Is our cosmos a one-time accident, a self-created loop, or a carefully edited projection? Does consciousness emerge from the laws of physics, or do the laws of physics emerge from a future act of consciousness? Every theory we have explored, from the divine clockwork to the human quantum leap, challenges the most basic assumptions of what it means to exist within time. They transform our history from a fixed record into a dynamic, living story, one that may still be writing its own prologue. The true value of this exploration lies not in picking a single winner, but in feeling the weight of the mystery. It stretches our imagination to its limit, asking us to hold contradictory ideas in our minds and see the beauty in the paradox. So now the question turns to you. After this journey to the edge of understanding, which theory bends your mind the most? Was it the haunting idea of the Boltzmann brain, a lonely consciousness willing itself into existence, or the cosmic humility of the alien archaeological intervention, where we are merely mold on an engineer's creation? Perhaps your intuition pulls you toward the poetic symmetry of the biological Genesis loop, where life itself is a gift from the end of time. Let us know in the comments below. Share your own favorite, debate the possibilities, and tell us what your gut says really happened at the dawn of everything. If this exploration of cosmic mysteries resonated with you, be sure to like this video and subscribe to the channel. Your engagement fuels this journey into the unknown, and we have so many more frontiers of space, time, and reality to explore together. Until next time, keep looking up and keep wondering.